With the name of Allah Almighty, dear students and all the viewers, may peace be upon all of you. Hopefully, you all will be fine. I'm Dr. Majid Amin, subject specialist mathematics, and my YouTube channel, Maths.Physics. We have started this course, 9th class mathematics. The chapter is matrices, and today, the third lecture, I am giving you the link, or you may go to the description, and the whole playlist is there. Students, today the topic is types of matrices. And before getting into the topic, I want to tell you there are so many other types of matrices as well. But of course, we are talking about, we have to remain limited to your 9th level. So these 10, 12 types are enough for you. So let's begin our lecture. First, we will discuss row matrix, or we can call it row vector as well. In some books, we use the word row vector. If it's not there, it's okay. You don't use it. Row matrix. A matrix containing one row only. If you have a matrix in which there is only one row, of course, it doesn't matter how many columns will be there. It is of no importance, but the main thing, it should contain one row. For example, if I give you this matrix, now you see a matrix in which there is only one row and columns are 2. Its size is 1 by 2 matrix. These things we have discussed in the previous lectures. Similarly, if we have this matrix, it is students 1 by 3 matrix. So we could have 1 cross 9 matrix, 1 by 9 matrix. All of these are row matrices. Generally, we say that, the size of a matrix we represented by, in the previous lecture, m by n, n number of rows, n number of columns. So here number of rows 1. So we write the size of row matrix is 1 by n matrix. And what is n? N is, you should mention n is a natural number, lest you should make a mistake. Sometimes students say n is any number may be 3.5, and of course number of columns can be 3.5. You could have number of columns 3, or you could have 4 columns. So this n is a natural number. It may be 1, it may be 29, it may be 103. So this is called the size of row matrix. Generally we say 1 cross n or 1 cross q, but q has to be a natural number. It is very simple. Row matrix and row vector. The second matrix, column matrix. The definition of this, just to save time, I have written them at the beginning. A matrix containing one column only. For example, this matrix, its size is 2 by 1. Students A, B, C, 3 by 1. So students, if generally you say its size should be m cross 1 matrix. A matrix having m rows and 1 column, and m is a natural number. M has to be a natural number. It is also called column vector. You got it? I think simple. Okay, students, this thing, square matrix, definition is a matrix in which number of rows and number of columns are equal. Having the same number of rows and number of columns, like in life we say it is square. A four-sided figure, this angle is 90 and length and width are equal. In the same way, a matrix in which number of rows and number of columns are equal, let's have a look at these two matrices. For example, 4, 2, 9, 3. Now students, it is what? It is a 2 by 2 square matrix. What is this? It is a 3 by 3 square matrix. It is a 3 by 3 square matrix. So the size of square matrix generally you will write as m cross m. Of course, m cross n, magar n and m are equal. Number of rows and number of columns are equal. Here we have 2, so number of columns are also 2, 3, 3. So if number of rows are m, number of columns will be also m. The size will be m by m matrix, or n by n, of course, k cross k. But we generally say m by m matrix. Let's discuss this thing, rectangular matrix. A matrix in which number of rows and number of columns are not equal. like this matrix. It is what? It is 2 by 3 matrix. Like in life, we say it is a rectangle in which in which the length and width are not equal. So students, what is its size? 4 by 2 matrix. Whatever is the size, but number of rows and number of columns are not equal, it has 4 rows and 2 columns. Generally, we say M by N matrix, and M and N are not equal. M and N, if you don't mention, still it is understood that M and N, they are different numbers. Otherwise, we would have used M by M matrix. But it's better that you mention them that they are not equal. M by N size, M by N, and M and N, they are not equal. So a matrix in which number of rows and number of columns are not equal is called rectangular matrix. I hope it is clear to you. Next, we will discuss zero matrix. Okay, students, what did I write? Zero matrix or null matrix. A matrix in which all the entries, all the elements are zero. The matrix could be square matrix or rectangular matrix. It makes no difference. It is a 2 by 2 zero matrix or null matrix. It is a, for example, 4 by 3 by 4 null matrix. All the elements are zero. It is called null matrix. Now, diagonal matrix. Okay, students, diagonal matrix, a square matrix in which all the elements out of the principal diagonal are zero. Second condition, at least one element of the principal diagonal is non-zero. So here you see a word principal diagonal. So let's discuss this thing first. What is meant by diagonal? In general life, we say if we have a closed figure, let's remain limited to four-sided figure like this. So we say when we join a corner to adjacent corner, it is called diagonal. Corner to adjacent corner is called diagonal. So the diagonal in general life can be made in square as well, and it can be made in a rectangle as well. But if we have, same as the case, corner to opposite corner, but diagonals in matrices, diagonals in square matrix only. Diagonals in square matrix only. Like this is a matrix. This is a matrix, square matrix, corner to opposite corner. So if you have a square matrix, then you will say that it is possible to have diagonals in that matrix. Corner to opposite corner. Similarly, corner to opposite corner. This one, these are called diagonals. This is what this is diagonal. This is what this is diagonal. So diagonals can't be made in rectangular matrices. How can you make diagonal in this? It's not possible that you go directly from 2 to 6 because you have to enclose elements, and if you do that, you can't reach the opposite corner. So no diagonals in rectangular matrix. Diagonals are not possible. Diagonals, they are must for square matrices. Number one. The second important point is that this is diagonal, but this diagonal which runs from first element to the last element, this diagonal is called principal diagonal. Let me check whether it is within the range of the camera or not. Yes, it is. It is called principal diagonal, or it is called main diagonal, or it is called primary diagonal. You can use these three words: primary diagonal, or main diagonal, or primary, which is of importance for us. Yeah, principal diagonal. And this one is called secondary diagonal. Both of them are diagonals. One is principal, other is secondary. Not that much important. Secondary, we say this thing is secondary. The marks is secondary. Learning is primary. So students, number one. As well as how do you define elements of principal diagonal mathematically? It is a particular matrix. So if you have a diagonal matrix and the elements of principal, if you see, I and J will be always equal. Aij, this notation we have used in the previous videos. I and J, A means element of matrix, I row position, J column position. So in diagonal matrix, the elements will have same I and J, all the elements we are talking about. For example, if we say this matrix, for example, if I write 3 by 3 matrix, generally A11, A13, A21, A31, A33. Right, students, if you see these elements, these are elements of principal diagonal. What is I over here? 1. J is 1, they are equal. Here I is 2, J is 2, they are equal. I is 3, J is 3, they are equal. And principal diagonal elements will have same I and J. And now if you see this is the secondary diagonal, I is 3, J is 1, they are not equal. 3 and 1, they are not equal. They are equal. Of course, here they are equal, but we are talking about all the elements. In secondary diagonals, I and J will not be always equal. In principal diagonal, always equal. You got the point. So, first of all, you notice that we have a thing called diagonal, and it is possible for square matrices only. So we have used the word principal diagonal. All the elements out of the principal diagonal are 0. Here first I give examples of not diagonal matrices. Not diagonal matrices. Just to save time, I have written them at the beginning. So students, not diagonal matrix 4, 0, 9, 0, 5, 0, 0, 0, 6. Now it is not a diagonal matrix because all the elements out of principal diagonal, they are not. This is creating problem. It created problem for us. If it had been 0, then it would be a diagonal matrix. All the elements, if you are talking about 3 by 3 matrix, out of principal diagonal elements are 6, all of them have to be 0. And if you are talking about 2 by 2 matrix, then out of principal diagonal are only 2 elements, this one and this one. You got the point, students. This is the first condition. The second condition is at least one element of the principal diagonal has to be non-zero. Like this. This is also not diagonal matrix because here first condition is satisfied, but the second condition is not satisfied. All the elements out of principal diagonal are 0. But at least one element of principal diagonal has to be non-zero. This is the example of, students, these are examples of diagonal matrix 4, 0, 0, 0, 0, 0, minus 3, 0, 0, 0, 7. Here, luckily, all the elements of the principal diagonal are non-zero. You could have this situation 4, 0, 0, 0, 9, 0, 0, 0, 0. I mean, you may have 0 in the principal diagonal. The condition is that at least one element is non-zero. Here we have 2 non-zero elements, non-zero. Even this is a diagonal matrix. 2 are 0, but 1 is non-zero, and the condition is that we should have at least one element, at least one non-zero element in the principal diagonal. Hopefully it is clear. Now, how do you define these things mathematically? Mathematically, we say that this thing. Okay, if I and J are not equal out these 6 elements, once again I tell you that if the matrix is 3 by 3 matrix, so these elements, 6 elements, here I and J are not equal. And if I and J are not equal, all of them have to be 0. Then the elements will be 0. Like you say A12 is 0, you say A13 is 0, A23 is 0, A21 is 0, and so on. So you can say that all the elements A12, A13 means in which I and J are not equal, those elements are 0. Out of principal diagonal are 0. And what is the condition on principal diagonal? At least one element is non-zero. So mathematically you say if I and J are equal means elements of principal diagonal, Aij will not be equal to 0 for at least for at least one aij, कम से कम एक element के लिए. I'm sometimes switching over to Urdu because I'm used to it. Before recording this lecture, I recorded that one. Aij is equal to 0 for at least one aij. For at least one aij, like here, at least one aij we have at least one aij in which I and j are equal and the element is not 0. That's enough. If these two are non-zero, okay, and if not 0, then still not okay. Still okay. Then students, it is what? It is the mathematical conditions of diagonal matrices. Let's discuss the other matrix, scalar matrix. All right, students, definition of scalar matrix. A diagonal matrix in which all the elements of the principal diagonal are same. For example, if you have 2 by 2 matrix, then this is what? This is a 2 by 2 scalar matrix. It is a diagonal matrix, but it is a scalar matrix. It is special case of diagonal matrix. In the first place, it is diagonal matrix. All the elements of principal diagonal, at least one is non-zero and outer 0. But then if the elements of principal diagonals are same, then we would say it is a special case. It is scalar matrix. Like we say, first of all, we are all humans. Then people like us who believe, and it is that there is one Allah and we worship Him. There are some conditions which are fulfilled by a person. We say he is a Muslim. So if he is a Muslim, of course he is a human in the first place. So it is diagonal matrix, but a special case, then we will call it the special name called scalar matrix. Students, this is scalar matrix. Generally, if I tell you write a 3 by 3 scalar matrix, so you may have 999, 555. So you use a general word, lambda 0, 0, 0, lambda 0, 0, 0, lambda, where lambda is a non-zero number. Yeah, you can use k or you can use k. So how to say these things mathematically? Now these are diagonal matrices, scalar matrices. All the elements out of principal diagonal are 0. So if I and j are not equal out of principal diagonal, those elements are 0. And if I and j are same, then aij will be equal to lambda for all I and j. The symbol for all. तमाम I और j के लिए वो सारे के सारे पे lambda होंगे. K, you can use k word, k. They are same, and lambda is a non-zero number. It is a definition of scalar matrix. Identity matrix, in which all the elements, they are same. And if they are one, then we would call it another special name called unit matrix or identity matrix, in which all the elements of principal diagonal are one. This is 2 by 2 identity matrix. This is, students, 3 by 3 identity matrix, generally represented by I. Generally represented by I, it is identity matrix of order 3. 3 by 3, we write 3 over here. We write 2 over here. Aij, if Aij not equal, Aij is equal to 0. If I and j equal, all those elements will be 1. It is called unit matrix or identity matrix. Next, symmetric matrix. Symmetric matrix. If A transpose is equal to A, then A is called symmetric matrix. What is transpose? You should know. If you don't know, then let me tell you. Transpose. If you interchange all the rows with the corresponding columns, the symbol for interchange. For example, students, if we have this matrix, by transpose A transpose, of course you will put transpose on both sides and then do this thing, but I am doing it directly. So A transpose means convert all the rows to corresponding columns, means first row will be converted to first column, second to second, and so on. First row will be converted to first column, second row will be converted to second column. We say that this is transpose of this. Like in common life, we say he is cousin of that person. Who is cousin? If the fathers of two boys are brothers, or their mothers are sister with respect to each other, and if his mother and his father are brother and sisters of each other, so we say these two are cousins of each other. Now you are not my cousin. It means no of those three conditions is fulfilled. So in life we say this is a boy and this is cousin. Likewise in matrices we say this is a matrix and this is its transpose. This is a matrix and this is its transpose. Because here rows of this matrix has been have been converted to corresponding columns. So if we have a matrix in which A transpose is equal to A, then it will be a symmetric. And students, the matrix must be a square matrix. If not, then this condition automatically can't be fulfilled. Like, give me an example. This is a matrix. 2, 5, 5, 9. If you take its transpose, my sweet students, first row will become first column and second row will become second column. It is A transpose. Both are equal. Lihaza, so A is so ko, so in Urdu, so is called lihaza. A is which matrix? A is symmetric matrix. A is which matrix? Symmetric matrix. If even there is difference of, let alone numbers, if you have 6, first row will become first column, then it is not equal, it is not symmetric matrix. And if there is slight difference of even a symbol, still they are not equal, not symmetric. They are not symmetric. A transpose 2, 6 and minus 6, 9, they are not equal. Corresponding elements are not equal. It's not symmetric. So they have to be equal numbers. Now, mathematically, you will define it as mathematically symmetric matrix Aij will be equal to Aji if you convert. For example, A12 will be equal to A21. It is a 2 by 2 matrix. We can't go otherwise. You may have a 3 by 3 matrix. I write directly 4, 1 minus 6, 1 minus 6, 5, 7, 7, 8. Like this. Now here you can see this is which matrix? This is A13. This is which matrix? This is A31. So you can see that A13 and A31 are equal. Similarly, if this is what? A23. This is A32. They are equal. This is what it means. Aij, if you interchange them, 1, 2, 2, 1, they will be same for all ing. It is symmetric matrix. Right, students, and it is of course a square matrix. If it is rectangular matrix, then even the size will not be the same. It is 2 by 3 matrix, transpose will be 3 by 2, automatically they can't be equal. It's called symmetric matrix. Now students, next is skew symmetric, in which A transpose is equal to minus A, then it is skew symmetric matrix. The condition is, by the way, symmetric means something having two equal things, equal portion, opposite to some line. For example, you have this face of a cartoon, or you say a human. If you slice this face with this line, so you see the portions opposite to this line, they are same, they are alike. Whatever you get on one side of this line is automatically present on the other side as well. They are also called mirror reflection. We say these two portions are symmetric, they are a mirror reflection of each other, or they are equal opposite to each other. Mirror reflection. If you take a mirror and place it over here and look from this side, you will see a full face. Likewise, you have this apple. If you slice the apple exactly at this point, we say, because I am not a computer, can't make exactly the same, but you assume that they are the same. These two portions, they are symmetric. Symmetry means a thing having two equal opposite portions with respect to a line. These two portions with respect to this line are equal. Symmetric. So in that particular case, that line is this line. Whatever you get, the numbers present across the line are also present below the line. that you find minus 6 at the distance above, automatically minus 6 at that distance below the line. Here is 7, here is 7, here is 1, here is 1, to which it is symmetric. Just to give you a hint. Now, in skew symmetric matrix, elements of principal diagonal are 0. And not on in the principal diagonal, they are opposite in signs of each other. So if you take transpose, first row becomes first column and second row becomes second column. Now they are not equal. But if you take minus, it will be 0, 6, minus 6, 0. If you take minus common, positive becomes negative and negative becomes positive because outside there is minus. If you multiply them, plus into minus. So, and there's no need to write minus 0. Minus 0 automatically means 0. Now this is A. This is A. This is A. So you can write minus A transpose is equal to minus A. A is skew symmetric matrix. So at the beginning, I told you the principal elements of principal diagonals must be 0. If, for example, this is 3, this is 3. Now, if you take minus here, you will get minus 3. And how will you call it A? It is not A. It is 3, it is minus 3. Corresponding elements are not same. Then it is not skew symmetric matrix. You got it? It is skew symmetric matrix. The other two, they are not generally given in ninth class. If it is given, then you study. If not given, sorry, I forgot to tell you the mathematical condition of skew symmetric. If I and j are equal, aij will be not equal, they will be 0. They will be 0 if equal. And if I and j are not equal, then aji will be minus of aij, negative of each other. Aji, for example, here you see a12 is 6, a21 is minus 6. So you can't say that a21 is equal to a12. Ijji, its value is a12 is 6, a21 is minus 6. They are not equal. But if I multiply it with negative, they are not equal. You see, they are not equal. But if I multiply a12 with minus sign, then they are equal. We say a21 is minus multiplied by a21. Same in magnitude, but opposite in sign. These two are the mathematical conditions of these two. Mathematical conditions of skew symmetric matrix. Skew symmetric matrix. Shown skew symmetric matrix. Students, Hermitian matrix is that matrix, Hermitian matrix. Straightforward, I write if M conjugate whole transpose is equal to M conjugate means changing the sign of those parts which contain iota. If you have gone through iota, imaginary numbers, then it's okay. If not, then you leave these two topics. You just understand the topics up to this point. If M conjugate whole transpose is equal to M, then it will be called Hermitian matrix, like this matrix. 4, 3 iota, minus 3 iota, minus 5. These two, this is called iota. Iota is a number whose value is under root minus 1. I will discuss this in the next chapter, number system. So if I take conjugate can't change the sign of real numbers which do not contain iota. The signs of the numbers having iota will be changed. Now, if you take transpose, first row will become first column and second row will become second column. It is now A. It is A. A conjugate whole transpose is equal to A. It is what? It is Hermitian matrix. And if you have minus M, it is skew Hermitian matrix. For example, my students like this. They conjugate, their signs will be changed. I'm just going through it. Bird's eye view. For example, you say it's my bird's eye view. You take minus common, it will be 0, 0, 3 iota, 3 iota. Now this is A, so it is minus A, hence it is what? It is skew Hermitian matrix. And at the end, I am giving you a topic called trace of a matrix. Trace. What is meant by trace? Sum of elements of principal diagonal. Sum of elements of principal diagonal, of course, he is talking about square matrix. Let's say we have this square matrix. And if he asks the trace of this matrix, you just add the elements of principal diagonal. It is called trace. A topic might not be there in your book, but I told you briefly. If you have a 3 by 3 matrix, what is its trace? Just add them. 6 and minus 7 plus 0. Minus 1 is its trace. Students, hopefully it's enough in this lecture. This lecture was a bit lengthy, and I told you in the previous lecture that our lectures will become lengthier and lengthier as we move on. Hopefully it is beneficial for you. Don't forget to share you with your friends. Remember me. We will see you in the next lecture, lecture number 4. Do remember me in your prayers. God bless you.